Hello everybody. This is example that I've shown at lecture very briefly about the that little library for solving linear system, sparse linear system. Is in the directory packs examples sources linear algebra IML eigen. I want to give you some more information about the content. Now in the include file, first of all, you find a little bit of stuff, the one that we have seen in lecture. But if you go to the linear algebra, so you go up one directory, you have this directory called utility. Now, in this utility, you find different things. The most important things is these mmreaders.hpp, that is just, I don't see, I hope you see it. It is just a modification that I made of the routine that are already available in Eigen to read and to read from matrix market file. I made a new version because the version that is originally shipped by Eigen in the unsupported section is really not very well done. So the main method are very simple, are just functions. Read matrix. You return you give the file name where you want to read the matrix, of the file storing the matrix in matrix market format, and it will return a sparse matrix type. And sparse matrix type is just the template parameter that has to be a proper sparse matrix of the eigen. So you just give a sparse matrix of the eigen and as a type to this method. This instead reads a vector, okay, stored in matrix market format. And the implementation, I will not go into much in detail about the implementation. The only thing that I want you to show is that I'm using this regex type of technique, regular expression technique, to identify if the files contain, if the file contains the keyword symmetric, because in that case it means that the file stores only the upper three-diagonal part of the matrix. So in that case, I will have to deal with the fact that in the file I only find roughly half of the matrix. So this is a rather sorry, I have to get out. No, no. No, I said no. Okay, and yes, right. Another thing that you find here is these utilities. Here you have some utilities to store for a simple class for the adjacency graph of the matrix. At the lecture we have told about adjacency graph. I told you that is not well, that there are the boost library, the boost graph library, where you really can handle very complex graph. Here I created a very simple adjacency graph with some utilities. It can get a matter. The co-data is just a structure that I have described that contains the matrix in a particular format, not the eigen matrix, but it's not so important. The important thing that with this class you can interrogate the adjacency, get all the nodes that are adjacent to a certain node, get the degree of a node, and is not well, is a very simple. And here there is a method make adjacency where you can pass a sparse matrix of the eigen, any sparse matrix of the eigen. And here you see this trick that I'm going to explain at lecture. And it will just return the adjacency graph created from this matrix. So that's it. There is no much to say. There is a constructor that is rather simple to understand, and there is also an utility that I've created to help if you want to apply permutation to an eigenmatrix. Because to apply permutation an eigenmatrix, you have to do a series of things that someone maybe forgets. So here what you do, you just pass a vector of integer, it can be any vector, and an eigenmatrix is a template method. So the eigenmatrix and the vector can be of any eigenmatrix type and any vector type. In particular, it can be a standard vector, and this standard vector contains the indexes, okay, the indexes of the permutation. And here you just use this vector to create an internal eigenvector with the indices. So you use V to create the actual indices, and then you copy the content of the vector into the vector of indices, and you create a permutation matrix by the famous twisted by, and then you return the matrix that has been permuted. So you take your matrix, you twist by the permutation, and it returns the permuted matrix. So if you want to apply the permutation to an eigenmatrix, instead of having to remember all this step, you can use this little utility. You just pass the matrix and a vector containing the permutation indexes. Okay, and I think that this could be rather useful. There are other things. There is also this Thomas.hpp. This is just a little routine that I wrote times ago to solve system in three diagonal systems. Three diagonal systems are very convenient to solve because you can apply the LU factorization. In fact, it's very simple, and is a so-called Thomas algorithm. Okay, so here it's very simple. You have to give three vector. C is just a template that has to be normally a vector, can be a standard vector, STT vector. Okay, and then you give the three vector defines the diagonal vector A, the diagonal vector C and B are the zero in fact, are the upper and lower diagonal of the trigonal matrix. Everything is commented, so all of the instruction on how to use it is here, and you pass also the right-hand side that here is called F for some reason, because B is already used for the sub-diagonal, and it will return a vector C of with a solution. So is a really simple routine. I will just remind you a few things. Decal type is a new feature of C++11. It returns the type of an object. So since A is a template argument, I don't know exactly what is the type of the size of A, which is normally an integer. And well, this would be, I tell you, these are a bit useless. You could have used here int, okay? but it's just to use a possible use of decal type. Okay, return the type of what a.size return, and then I will initialize n with that value, and the rest is just a smart use of vectors. Remember, in place back, they just add a value to a vector, and then eventually I return the result. So this is Thomas' algorithm. You find it in many books. It's very simple to understand. There is no much to say, in fact. Sorry. Now I'm using Vim. Sometimes I use Vim, sometimes I use Emacs, and I get. There is a README file, and if you want to, you do a sorry, I've not said makefile.inc, but anyway, you have to do make install, so that all it will create a library, and it will install the header file and the library at the right place, so that you can use this utility for all tests. Okay, while in IML again, as I told you, you find in include all the different possible methods that we have seen at lecture. GMRes, for instance, all described, commented, and all methods, in fact, work more or less in the same way. Okay, you pass the matrix, you pass the vector, the initial value that will return the approximated solution, you pass the right hand side, you pass the preconditioner, that is any object that has got the method solve defined, whatever it does. M is the number of restarts, because this is GMRes with restart. So here is the number, the length, if you want, of the GMRes. So this is GMRes M, okay? The maximum number of iteration and the tolerance. Now, as I said at lecture, this type name vector scalar tol is not very nice. I will change it. You will find now a new version where this is just double, okay? Because it is more consistent. It will be just a double, okay? But you will find that in the next days. Okay, what else? This iml.hpp is just a header file that includes everything. If you have a program where you want to choose any of those methods, you have to include all the other files, of course. So instead of remembering what you have to include, I've made this iml++.hpp, and you can load that file instead. What I want to show you again is something that you find not in examples, but in extras. In extras, you have linear algebra books and notes. And here there are very nice things. There is, well, this sparsely ++, which we are not using, but you have the books, the book of SAD, sparse matrices.pdf, if I'm correct. Let's see. I cannot connect because I'm anyway. Sparse matrices.pdf is the book of SAD. You have templates for iterative methods, linear systems.pdf, that contains all the details of the code that are in that directory. So that code is described in very detail in this book. So this is a very nice book, and there you find the description of all the method that you find in that directory. okay, with also some more technical detail about the properties of each method. Okay, so it's a very good book. So, and you have it for free here, also because it can be downloaded anyway from the web. Then what you have, you will have also the method for the eigenvalues, but that will be part of another future video. And you have a directory called Matrix Market IO, where you have the documentation, not only some other programs to read from Matrix Market file, but you have these files, mmformat.ps. I don't know why it was in zipped format. I will change that. And that file describes the matrix market format. So if you're interested in knowing how the market format, file format is made, how it is organized, you find everything there. I will put also the PDF version. Actually, I will push the PDF version if you don't want the PS version of the file. You also have a file that explains the Harwell-Boeing format, which is another format for file storing sparse matrices and sparse vectors, which is rather complicated. But if you're interested, if somebody gives you a matrix in Harwell-Boeing format, in that user guide you find the description of the format. Okay, and then you have also some other files for reading and writing in matrix market format, but those are routines written in C. As I told you before, I made a wrapper for the Eigen library. You can use that one, but here you have all other routines to read and write from matrix market file, a routine made in C, not in C++, however.